$30,000, salvage value at 5 years, $7,000. What is the equivalent uniform annual uh, or capital recovery cost at 10%? Uh, so, because right now you asked your question before, we used to see equivalent uniform annual, if you remember from the other slide, the past slide. If you see here, we used to see the equivalent uniform annual work. But in this specific case, it's going to be the equivalent uniform annual cost. Why is cost? Because we are referring everything just to cost, right? So it say that machine cost $30,000, so that's the cost, zero. We also have here a salvage value at 5 year, at year 5, uh, which is equal to $70,000. So what you do something very easy. What you do is, if you see the cost, which is going to be very high, will pass from P to A with a 10% for 5 years, and then you will have the $7,000 that you will pass from future, because it's at the year 5, to A with the 10% within the 5 years. If you do the multiplication, it's going to be negative, correct? But because you already are saying equivalent uniform annual cost, because it's negative, you are referring mainly to the cost. So that's the reason why we call equivalent uniform annual cost. No? So it's going to be negative, correct? Most of the time, it's very important to mention that that it's important to mention that every time that we work with annual cash flows, we need to pass everything to the annual. That's the secret. Everything, cost, benefit, everything need to move to the annual. Right? Let's see this example very quick, in which explain about how we calculate the annual cash flow calculations. For instance, here, in this specific case, you will have a P, you will have an end time, and then you will have a salvage value, a S. So most of the time you pass P to A, as you see here with the I, with the interest rate. So if you see the next, so what we are doing is we are passing everything to A, so we're giving annual values, correct, from the P, from the S. Then we are also passing the values for S to A. So we have 8888888. So subtracting the cost minus the benefit, you will have different values of annual that you will need to put as a cost or will be as a benefit. But this is another secret that I would like that you understand. Because you have APIN and those AFIN, if you see both of them are almost equal. No? Here you have a present, here you have a F, you have an I, an N. So another way that they are saying that can be calculated is P minus S, AFIN plus PI, or EUAC equal to P minus A, so that A divided by P, IN plus SI. Now, to be honest, what I would suggest you is do this very simple way, because right now we're in the learning process and you guys will be able to to, to do it in simple way. Because if you come here, you will ask, why is the reason why we add P here when we are having to F of A? And what is the reason why when we have to A to P, we add S, which is going to be the future value, correct? The reason is only formulas. If you start to do the same equations and you insert the formulas, you will realize that the P is coming from joining these formulas with a minus, and the S is coming the same thing, joining that formula when you are focusing in A to P. So for reason of this course, I will strongly suggest that you focus only do in a simple way. Follow P from A to P with I and N and S. The main reason is we're passing everything to A, but do it step by step. Don't try to join like you said here because you can get confused. Okay? Now, let's start to talk about the example number 3. This is a very interesting example because what you will have here, you will have for different years, year 1, 2, 3, 4, 5, you will have different maintenance and repair costs for each year, 545, 590, 65, 680, 725, and the interest is going to be 7%. So here, what we need to do, you will ask me, but why do we need to have a why would it, do we need to have how we can going to be able to calculate it because we already have it as an A value. You see, A value with increment of G, correct? So my suggestion is very simple. It's very simple. What I would suggest you is you will do it in two ways. The first way is going to be you can calculate the equivalent uniform annual cost if you pass all these values, right, to A. Or on the other hand, what you can do is pass all these values, correct, to P, and then from P you will pass again to A, right? But both of them should give you the same answer. That could be the possibility. So how we're going to do that? Well, you know that the constant value that you will pay is going to be 545, and the gradient is going to be 45, correct? 545 plus 45 is going to be 590. 590 plus 45 is going to be 335. 335 plus 45 is going to be 380. 380 plus 45 is going to be 725. So you know that the A value is going to be 545. So you can do 5 equivalent unit annual cost. Equivalent uniform annual cost is going to be equal to 545, correct? Plus 45, which you're going to pass from gradient to A with the 7% with the 5 years. If you do the exercise 545 plus 45 times 1.865, it's going to give you 629. So that will be your answer because again, the secret here is that you have to pass everything to A. In present world, we evaluate everything passing to present world. We evaluate everything passing to present, correct? But now in annual cash flow, you everything passing to A. That's the main difference. And here, how they have been done using the computer is also a very simple way to do it. What they have done is mainly passing everything to present cost, and then from present cost they have passed everything to A. But at the end they give you the same answer, correct? You see 629 here, we got 629 using the same procedure. So again, this is passing from G and everything passing to P, to present cost. So you pass everything here to P, and then from P, what you do, you pass to A. Then you have, this is a longest step. This one is a very shorter step, right? So the reason why they are explaining here is because if I remember correctly, there is no formula that you can pass from A to G in Excel. They are using here the function NPV, net present value. So that's the reason why they are doing this procedure here, correct? So that's actually the main reason why they are doing. You see here, they are going from A B5 to B9, B5 to B9. So they are doing all this to the calculation, correct? With, starting from the time that is considering a 7%, correct? And based on that, they are able to calculate this net present value. So everything here they are passing to NPV, to present, and then from here to equivalent uniform annual cost. But again, I want that you guys understand that this is because this has been done in Excel. For us, which again, we are taking examples. So for us, this is going to be our answer. We pass everything to A, having the formulas that you guys have in your spreadsheet from A to G. Right? Now, let's do this another example. Uh, what happens if you add another cost of 750 during the year 3? How you're going to solve that, correct? You have five, in the example, we have 545, 690, 635 plus 650, and then 680, 625. So you see here, now we are having an increment of 750. So how you're going to solve that? That is also going to be very interesting. You will apply the same formula here, but this 650 will be a future at the time 3. So what you need to do is pass this 150, which is in the future, to time 3. You will pass to this 650, you will pass to P, and then from P you will pass to A. Or you can pass the 750 straightforward to A, correct? But no, I apologize. You need to have this 150 to P, because if you pass to A, only will be covered the 3 years, because this one started in the year 3. So you will have calculation of A for the year 3, the year 2, and the year 1, but you will not have for all the years. So that's the reason why you have the 750 that is in present, that is in future. In the year 3, you pass to present, as you see here, and then you convert from present to A. So you are having this 755 annually distributed for the 5 years. And then you will have your 545, and then what we have done with the 545 increment. Based on that, you will calculate that your equivalent uniform annual cost is going to be 778.24, correct? 778.24. So yes, that's the main reason, the main point to how we can calculate this. Remember, don't change from this because this is F at the year 3, don't change to A, because A only going to allow you to have annual from the year 1, 2, 3, but you are missing year 4 and 5. That's the reason why we need to pass from F to P, and then P we distribute it during the 5 years. Okay. Now, this is another question. A machine requires a 100K overhaul in year 5. Overhaul is like an increment of cost that is happening in the year 5 of 8-year life. AUC of overhaul at I equal 10%, what will be the answer? So I will leave you guys this for your homework, but this is going to be very straightforward because you have this 100K in the year 5. What you need to do is you pass this 100K in the year 5 to A, and then from the year 5 to which is going to be F, you will pass to P, and then you distribute it during the 8 years, correct? That's how you are going to solve. And this should give you answer of 11.64. Now, we're going to discuss situations of annual cash flow analysis. We're talking about, for instance, when you have a situation where you have the criterion of equivalent uniform annual work, right? Equivalent uniform annual work, which is going to be equivalent uniform annual benefit minus equivalent uniform annual cost, as you can see here. What you want to do is maximize to get the the, the alternative, correct? You want to decide, you want to take in consideration the alternative that have the highest LAEUAW. That's your goal. When you have a fixed input, correct? Only what means you just have benefits. What you want to do is you want to maximize the equivalent uniform annual benefits, correct? That's your goal. Just maximize the equivalent uniform annual benefit because this is a benefit. So you want to keep it as high as this is. And when you have the equivalent uniform annual cost, you want to minimize, correct? Because you want to minimize cost. Again, every time that you see EUA, equivalent union annual, is the same thing that we were discussing in present world. In present world, you take everything to present, to 0, but here in equivalent uniform annual world, you pass everything. You are passing to A. That's the every time that you see EUA, you know that you have to pass everything to A, which is annual. Correct? Now, this is a very interesting example because what they are giving you here is they're giving you two alternatives, device A and device B. Device A, as you see, have 5 years with an interest of 7% in both of them, and then you have an n equal to 5 years. You have a present, which is $10,000, which, as you see, the arrow is going down, so it's probably a cost, and then you will have a benefit of $3,000. In device B, you will have an increment, correct, of 3,000, 3,500, 4,000 of every year, and then you will have a present worth of 13,500 in 5 years. So if you see here, it's more probably you can analyze. What you need to do is you will have a benefit and you will have a cost. So what you want to make sure is that you understand what is going to be the highest value, correct? If you know that the cost is going to be the highest value, we are looking at equivalent uniform annual cost. Here the same, in the other, in device B, the same, 13,500. The cost is higher, so we're talking about equivalent uniform annual cost, correct? So if you see in the example, what we need to do is this P here, we need to pass to 8, 7% of 5. So we're passing this minus 10,000 to 8. And this 3,000, we leave it how it is because it's already a 8, correct? So when you do this, we obtain 561. Again, because negative is the higher one, correct? This is higher. Sorry. No. Here there is, I need to correct. Here is the equivalent uniform annual worth. It's not annual cost. There is a mistake here. Why? Because if you see, you have here the cost and you have here the benefit. The 3,000 is the benefit because it's going to another way. So it is going to be a equivalent uniform annual worth, no cost. Okay. So if you do this subtraction, you will be able to see that the total is going to be 561. Correct? Again, the only one that we have passed away has been the P. In the other case, it's going to be very straightforward because you have already the A3000 and you need to pass the 500 increment from G to A, and then you will add both of it, and then you will have the 13,500, which is going to be negative. You will pass to A, and at the end you will have 640 because it's an equivalent uniform annual worth, no cost. I already correct myself. You will remember the criterion is you will take that one that have the maximum. So your answer will be here, 640 is going to be your answer. So the best alternative is going to be device B. Okay. Now, this is also another interesting problem. 6.6, we're going to do something very interesting. We're going to have different plans, plan A, plan B, and plan C. We have the installment equipment cost, we have the material labor savings, per year savings, remember, are not costs, are savings, so that means a benefit. Then we have the annual operating expenses, which is a cost, salvage value, which is a benefit. It's very important when you're doing this type of work that you analyze, identify what is cost and what is benefit. Correct? Here again, installed equipment cost is already a cost, material labor savings per year, annual operating expenses, and salvage value. Salvage value is a benefit of annual operating expenses is a cost, and material labor savings is a benefit, and installed equipment cost is a cost. So you have 15,000, 20,000, 8,000, 1,500 dollars for the different plans. Now this is you have different three plans. So you already when they are telling you the material labor savings per year, you know that those are already A. So that's per year, so are a benefit that you will have for each one. Then you have the salvage value, which you already know that is a future, correct? So you have already the interest is going to be 8% and the time is going to be 10 years. So you pass this F to P, correct? So you will have, sorry, you can have pass this F to A, correct? You can pass F to A. So you will have these two values for plan A, for plan B, for plan C in A. And then if you do the equivalent uniform annual benefits, it's going to be, which both of them are the benefit, this one and this one will be these amounts. Then you will have the installed cost, which is going to be a P, but you are passing to P for A with 8% within years. So you will pass, your which is 15,000. You will pass for annual cost of 2,235, 3,625, and 4,970. And then you will have annual operating expenses, which is going to be annual. You don't need to change nothing, of 8,000, 6,000. You have your equivalent uniform annual cost will be 200, 235 plus 8,000. B will be 3,725 plus 6,000, and then 490, 970 plus 6,000. So at the end, you will have two values, your equivalent uniform annual benefit, and then your equivalent uniform annual cost. If you subtract of them, you will calculate equivalent uniform annual worth, which is going to be 3,869, 553, 3,311. As we remember, we want to maximize the equivalent uniform annual worth. So we're going to decide for this one. Okay? This is very important because we are deciding for the highest, which is this one. Correct? Now, imagine that we only have focus, this is example, in only the equivalent uniform annual cost. So you know that it's minimizing, correct? So what we're going to decide? We're going to decide plan B, because this plan B have the lowest. However, and what happens when we focus here in the equivalent uniform annual benefit? We want to maximize, so will be this one, plan C, that one that you're going to decide. The message that I want to convey to you is not necessarily going to be very transparent if you just only focus on the equivalent uniform annual benefit or the equivalent uniform annual cost separately. That's the reason why the equivalent uniform annual work is the best measurement to know what plan to go, what decision to take, what alternative to take with your project. And this is a good example. Each of these one give you different alternatives, but the end, that one that you want to decide is the last one. Example 6.7. Now, this is very interesting because what we see here in this example is giving the use of two different pumps, pump A and pump B. The initial cost of the pump is $7,000 and the salvage value is $1,200 and $1,000. But listen here, the useful life is going to be different, correct? It's going to be 12 and 6. For pump A is going to be 12 and 6. So how we're going to work with that? If you remember when we're doing this in the present world, what I mentioned to you, it will be repetitive, correct? Let me see here. For instance, if we focus in the pump A, correct? In the pump A, which is going to have 7,000, 1,200, correct? And it's going to go for 12 years. That is very straightforward. Because what you need to do is you have the initial cost, which is going to be $7,000. Then you will have 1,200 at the end of the year, correct? At the end of the year. So what you need to do is you need to move the 1,200 to present, correct? 1,200 to present. Or if you want, you can move the 1,200 straight to A, from F to A, correct? But here, what they have done is moving to present. So doesn't matter. What you can do is you can using this formula. But again, as I told you, that the formula that was just mentioned to you, just do it in the simple way. So you will have your initial cost, which is going to be P. So you move $70,000 from P to A. You already know the formula for an interest of 7% in 12 years. And then you will have $1,200, which will be at the year 12 because it's the salvage value. And then you will move to P, to P, and then from P, you will have your $1,200, which is F at the year 12, and then you will move to F to A, right? From F to A. And then if you do that subtraction, you will be able to calculate the equivalent uniform annual cost. Again, here it should be equivalent uniform annual worth because salvage value is going to be a benefit. So here it's going to be equivalent uniform annual worth. You should be able to calculate, and please, right now, because I'm in a video, again, I have to travel because I'm traveling. I will want that you guys please do this by hand. I'm just giving you time in the video. You can stop the video. You can do the calculation, return again to listen to me. So that's the reason why I'm not saying do the exercise, do the exercise. Now, you guys can do it. Just stop the video and then you do the multiplications and then you will be able to see the answer. So if you follow what I am saying, please see the answer here. Now, that situation is going to change a little bit with the pump B. What happened? Because you will say, remember when we say, you will have the initial cost of 5,000, which is going to be P, and then you will have the salvage value, but at the year seed of 1,000. But if you remember, we say that when you have 12, you can repeat. Remember, it's like a multiple. So from 0 to 6, you will have 5 in the present and 1,000 in the future, 6. Because you are comparing with another one that have 12, you will have in the 6, which will kind of be like 0, is going to have your 5,000, and your 12, you will have your 1,000. So the same principle here. So you have your P. What you're going to do is you will pass your P. What I would suggest you to do is this is going to be also F6. So move this F from 6 to P here. You have two P's here, and then you will move this 1,000, which is in 6, and you can put it as a time 0, and then you move it to 12, which is going to be 6 years with an interest of 6%. So you will have 2F here and 2 P's here, and then the same principle, just move this F to A, distributing for every year during the 12 years, and then these P's, these 2 P's, you add them, and then you distributing during the 12 years. And then you subtract them, and then you will calculate the equivalent uniform annual reward, and you should get close to 909. This is a very interesting exercise because we have done it before. Again, it's just, as you see, it's just because, again, we're repeating. You see, 5,000 initial cost, salvage value 1,000, year 6, and we're comparing with one that is 12. That's the reason why we are expanding, correct? A multiple. So the multiple is going to be, because it's double, is going to be 6 plus 6 is going to give you 12. So that's the reason why we are doing 5,000, 5,000, 1,000, and 1,000. So this is, we just repeating, correct? 5,000 for the 1,000 for the year 6. We consider 5,000 like 0, and then 1,000 for the year 12. We move this F from year 6 to year 12, which is going to be like you are moving from 0 to 6, correct? 0 to 6. From F here, from P to F, you move it here, you will have to F, and then this is going to be your F 6 to 0 to P. So you will have two P's that you will pass to A, from 0 to 12, and then you will have your 2F that you will move to A from 12 to 0, or 0 to 12. With the interest, remember, of 7%. Okay? So I'm sure that you guys will be able to do it. This is a very interesting exercise. Again, please stop the video, put pause, and then do the calculations, and then come back again, and then redo the calculation. As I mentioned to you, with this we're going to cover chapter 6. For right now, we are not going to have homeworks. In case that you have any problem, please, no worries. I will see you guys no the following week, 1 week after it. So I will go to you if you guys have any question. I will answer your questions. But again, this is very straightforward, very easy chapter. Similar to present world, the only situation is you move to A. And again, and again, please do the exercise. Because if I continue talking and telling you from F to P, you will not be able to understand. But if you do the exercise every time, like you follow this video with doing the exercise with your calculator, is when you will be able to get the answers. Okay? So that's it. Chapter 6. Again, I will talk and I will see you guys not this coming week, next week. Okay? Thank you very much. Have a good